This is my petrol powered mulching lawnmower, and this is my four-wheel drive radio controlled vehicle kit. I'm going to combine the two to give myself a radio controlled mulching machine. Yes, I have been watching Jeremy Clarkson have too much fun with his robo flail. You can already buy radio controlled lawnmowers. There's loads of them available from China. They usually have tracks or wheels and tyres like this. They range from about £1,500 to £3,000 plus shipping, so they're quite expensive. So this is going to be a much lower budget version and a lot smaller. You may already know that my first passion was Lego as a child, and my second passion was radio controlled cars. I built loads of radio controlled vehicles. It's one of the things I've always enjoyed doing, so building something like this is just going to be enormous fun, and it's going to be useful because I have some pretty difficult terrain outside. I'll show you that in a minute. But before I go too far into this project, I better find out if my second-hand lawnmower purchase actually works. Well, I'm pleased with that. The mower started really easily and it's cutting the grass really well. In fact, the grass is probably way too wet to cut right now. It's areas like this which are pretty hard to cut by hand. Trying to push the mower along a gradient or up and down a gradient is just hard work. In fact, it wants to tip over. So this is where I hope the radio controlled beast is going to be way better. Feels like I'm going to have to make it very low center of gravity and also quite a wide track. Oh, it's going to need a lot of power too. Let's take a quick look at the donor lawnmower for this project. It's actually a mulching lawnmower by a company called AS Motor. I think that's a German company. And a mulcher differs in the fact that it just chops the grass up inside of the deck here. It doesn't collect it and it doesn't eject it, which is ideal because effectively I'm rough cutting a lot of this area. And the push handle has to go, but I'm hoping to keep the height adjustment. I've deliberately gone for this linked height adjustment on a single axis here. So if I pull this lever, you can go up and down with a single lever, and that means that I could add a linear actuator to control that. So what I will do is build a frame around it and then add the wheels to the frame. So that should be quite a simple procedure, and I'm utilising some of the lawnmower's existing mechanism. The drivetrain for this mulching mower is going to be this kit by Alfaster, and they did give me this at a reduced price, but it was still $370 shipped. It comes with 4 of these motors. Each one of them is a DC motor rated at 250 watts. That's 24 volts. So that's about 10 amps per motor. And it comes with these set of wheels. This is the off-road tyre. They also do an agricultural tyre, which is more like a tractor grip, but I think this will be better for my purposes. I also purchased the motor mount bracket, so that should be easy to fix to my frame around the mower. And I got their electronics kit, which is the motor control board here, which controls 4 motors, and it came with this RC nunchuck style controller. It's literally just a radio controlled receiver plugged into the control inputs of this motor controller, which I'm guessing is forwards, left and right, and it does the mixing internally. So if I want to change the control method, like to an Arduino based system, I can simply send PWM signals into this motor controller. So that should make it nice and easy to customize. The first step of this project is going to be building all these parts in my CAD package along with a model of the lawnmower. That way I can work out how the chassis is going to attach. Before I immerse myself in CAD, I'm going to give a quick shout out to my podcast channel, Denton's Den. I interview various people I've met throughout my career, mostly creature effects people so far, and there's already 5 episodes. So head over and check that out. It's Denton's Den on YouTube. Also available on Spotify, Apple and Amazon. I'll leave a link in the description below. Here is the Alfaster motor and bracket assembly, and here is the AS Motor mulching lawnmower model. The engine block is very basic, but it gives me its outer dimensions, but I have modelled this mechanism, which is the height adjust mech. The current idea I have is to remove the wheels and then build a frame around the outside, which will then attach to my new set of radio controlled wheels. Here is the lawnmower fitted into my basic frame, which is 2060 extrusion with some custom motor brackets. The problem is it makes the wheelbase very long. and it's because I'm trying to utilise the existing lawnmower's lift and raise mechanism. The problem with having a long wheelbase is that it won't want to skid steer very easily. So I decided to remove the front and rear axles and bolt directly onto the chassis. This might save a bit of space, but actually it didn't really make any difference. To get the same 60mm of travel up and down, I still have to move forwards and backwards 60mm on the same framework, which is just a waste of space. So the wheels have to go, the front and rear mech, the chassis, and what I'm left with is the deck and the engine. Here's where I'm at with the current design. It's a much stockier looking machine, and you can see I've managed to get the wheelbase quite a lot shorter. I've also gone a little bit narrower so you're not missing so much grass on the sides. The deck is now mounted with some 2060 extrusion, like the rest of my chassis is made out of, and that is also mounted via some linkages up to a linear actuator. Of course, this can be raised and lowered to set the height of the cut, and in the highest position should be out of the way so there's maximum clearance underneath. Okay, let's get this machine stripped down. Yay! If there was one ball left in the ball bearing, now there's none. Which way does the nut on a lawnmower blade spin? Anti-clockwise when viewed from underneath, which means that it's standard thread, and anti-clockwise spinning blade when viewed from the bottom. So anti-clockwise undo the nut. The Torx bits. I'm going to try the impact driver. I really don't like using them on small rusty bolts like this, but I can't seem to get any purchase or torque on this. It's not stripping it, but it isn't moving either. I really don't want to break them. I thought I'd try one last trick to get this moving, and it's worked, and that is to go forwards a little bit before you go backwards. I've also soaked them in WD-40, which is probably helping. The problem with lawnmowers with steel decks is they always end up rusting. So you do have to kind of look after them, which most people don't. This one isn't too bad, to be honest, but once I got it apart, I should probably give it a coat of paint just to protect it. Yay! Number 2. There it is. I hope that's supposed to drop out. Steel on brass, there's like no bearing. Well, whilst I've got the deck off, I suppose it's a good time to clean it up and maybe give it some fresh paint. I've had a tidy up and I'm ready to remove this engine from the frame. Now that's good, the keyway has stayed in the motor shaft. So this is what I'm left with. The engine, the blade, the engine coupling and the deck. Yeah, I'm well aware that I could have bought all these bits individually now. I genuinely thought I was going to use the chassis and raise and lower mech, but there we have it. These projects change as they go along. Let's move on. While the deck is off, I thought it would be a good idea to give it a bit of freshen up. So first of all, I remove all the flaky paint and rust, then give it a bit of a spray out with some brake cleaner. Next, I'm going to apply a layer of hammerite crust. This kills the existing rust and turns it black and blue in colour. Then you can paint over the top. 1 hour later, you can see the crust has turned black. I'm going to paint with 2 coats of hammerite red oxide paint. While that's drying, I'm going to crack on with something else. There's no determinable pattern on the engine mount holes, and I couldn't find a specification sheet online so that I could take them from a drawing, so I've had to take some very careful measurements. I can now transfer these measurements onto my engine mount flange, but I will have to redesign the flange slightly because at the moment one of the holes goes right through one of the folds. The 2060 extrusion has arrived, so I'm going to cut my chassis pieces to length. This extrusion was slightly cheaper because it was classed as seconds, however I wasn't expecting it to be partially anodized on one side. Having carried out all of this design in CAD, I feel it's time to start assembling the chassis so that I can test that it all goes together. Once the chassis is assembled, I can also test the radio control kit. As of now, I have no idea if it's going to be powerful enough, or the right speed, or whether it's going to work. I'm trying to keep the assembly as square as possible as I go. I may need to adjust this once it's all together. I'll print the corner blocks on my Bamboo H2D printer. Once I'm happy everything fits together well, I'll reprint these with more infill and perimeters and in a high temperature PLA from Polymaker. You can see the CAD model wasn't quite correct because the holes don't line up, so I'll just fit these together with a single fitting for now, just so I can test this chassis build out. In order to make the chassis design easier, I put these holes where I needed them rather than trying to line them up with the slots, so I do need to drill a couple of holes in the motor plate. I'm going to use a simple 3D printed template. This locates in the existing mounting slots and gives me the position of the new holes. There's a little fiddly getting this whole chassis bracket assembly together, but everything's finally lining up and I now have 2 sets of wheel brackets. These corner blocks have aligned really nicely with the corner of the chassis, but the beauty of using extrusion is that it's easy to adjust. The output spline on the motor and the hub on the wheel have a matching keyway to stop them from rotating, and they're held in place with a single bolt and washer. I may add a small amount of thread lock or an anti-vibration washer as well. Oh God, I love it. I need some air in the tyres because they're flat. Imagine what it's really like when this engine's on and all the orange detailing and stuff. It's going to look epic. All I have to hope is that it actually works, because there's a lot of weight, and to skid steer something takes a lot of torque. Now I've gone for the slightly higher speed motor set, so they do up to 6 kilometers an hour. There was a higher torque, lower speed set at 4 kilometers an hour, but I thought that was a little bit slow. But I'm hoping they're still powerful enough. I mean, it's 1,000 watts of power. But the only way to find out is to get the motor controller on here, some batteries, and then take it for a little spin. I've just temporarily fixed the motor controller here, and I've got a 22 volt LiPo battery to run it all on. Let's power up. Got a big fan, I've got a flashing lights, turn the controller on. Perky sound. That's gone solid green, that's good. Let's just try it. Hello. That looks really fast. I mean, for a lawnmower, it's way faster than 6 kilometers an hour. Oh no, have I gone for the... Should I have gone for the high torque? So to go left, that goes forward and that goes backwards. Yeah, that's right. It sounds nice. Sounds nice and smooth. It's responsive. It just looks really fast for 6 kilometers an hour. I really hope I've got the right one. Let's get it on the floor and try it. It is turning pretty well, but then this floor is slippery, so I would expect it to. The slow speed control, that's about as slow as it will go. And I feel like there are times when you'd want it slower than that. Is this a terrible idea? Okay. Well, that's got plenty of power, and it will steer on the spot with 85 kilos on it. That's pretty good. Not bad at all, but it does seem pretty ferociously fast. Like, the acceleration is crazy. It's too much, really. Well, there's not much I can do about that. Of course, there are things that could be done. For example, I could run it on a lower voltage, like 12 volts, so it would halve the speed. The problem with that is you're only going to get half the power, so it's going to reduce the output power to 500 watts. That might be enough, so maybe that's an option. I could replace all the motor gearboxes with the 4 kilometer an hour versions, but that might be quite expensive. Or I could try the option of contacting Faster and see if it's simply a case of swapping some gears out, because they might do a replacement gear sets for these, and I wonder if the casings are the same, it's just a different gear combo that goes in there. So I'm going to try that first. I know it sounds weird, I'm sure people are going, you want it as fast as possible, but actually when you're trying to do precise things like mowing a lawn, you need control at slower speeds, and at the moment this feels like it's going to be too difficult to control at low speeds. I want to continue the build anyway, obviously, and try it out, but that's my first concern. I think it's too fast. I've just received a shipment of a couple of reels of Polymaker's new high temperature PLA in orange, which looks beautiful, especially when you see it next to the deck that I've resprayed. Look at that. It's going to look peachy. So I'm going to load this into my Bamboo H2D printer and print these parts out in a much stronger version. And whilst that's going on, I'm going to take this outside and test it on some rougher terrain. My very weak PLA mountings gave way very quickly when I tried to turn it. So yeah, I got carried away with my test rig there, forgetting that I'd only put 2 bolts either side. It ripped through the bottom layer, maybe the top layer actually, and there was only 2 perimeters and very little infill. I've printed a new one which has double everything, so I think it's 4 perimeters, double the infill and double the bottom, top and bottom layers. But the more important thing now is that I'm printing it this way on the bed, and this one was printed this way on the bed. So the layer lines are much better aligned when it's mounted on the chassis. I'm also going to add some additional aluminium extrusion. I'm going to bolt through the back of the motor plate, through this part here, and then into the side of the chassis member. I'll also add some steel webbing for strength, then test it all again under some proper load conditions. Here's the new completed chassis. I've got my additional bracing down to the motor plates here, and I've got some additional cross bracing across the chassis which also connects to those down braces to the plate, and of course the new and improved 3D printed corner blocks. I'm going to stick the wheels back on and then take it for another spin. Oh god, this is going to be a 2-man lift. Well, this is the point where it failed yesterday once the traction in the grass was too much. Well, I don't know about cutting the grass, I can just tear it up with the wheels. Well, that seemed to be behaving pretty well. Of course, I've got to try it under load, so loads of power. I don't know about turning. Oh, well, God, that's churning the grass up, but that's way too much load for this. It's working pretty good because it's going to be at least half my weight, at least. Woo! I'm currently waiting on some parts to arrive, so I thought it would be a good time to take a look at this engine, how it runs and how I'm going to control it. This is a Briggs & Stratton engine, 140cc, and I'm going to leave it as a pull start, so you have to manually start the engine, but I need to be able to remotely stop it. So I'm going to start by taking this pull start lid off. So what we have under here is the pull start mechanism, which attaches to the underside of here. This here flywheel, if you like, with cooling fins. It's really quite a neat design because effectively it sucks air down through and over the engine fins here to cool the engine. But it also acts as the spark generator, this piece here. So as this spins around, there's 2 contacts here, and that generates the spark with the correct timing for the engine. I love the simplicity of it. Here there's a piece which goes into the exhaust pipe, and this little lever here which comes across. So this is the carburetor, and this little lever is attached to it, and in here is the air intake and air filter. So this is effectively like an automatic choke. So when the engine's cold, this sits here, and when it gets hot, this moves across and changes the mixture. The thing I need to be able to do is to stop this engine remotely. And currently this cable here is usually held on by the user on a big grip to enable the engine. And what that does, it releases a brake off of this spinning mechanism, and it also disengages this little very basic switch which shorts a wire to the chassis. So the brake is quite obvious. It slows down the engine. So as you release the catch, this brakes itself. So at the moment, this is quite hard to turn because the brake is on. But the little electrical contact comes down onto the spark generator here, and it looks like it shorts this out, so it also stops the engine by shorting the spark plug out. So that's how I can stop it remotely. I can short this to ground with a relay and stop the motor. So now I know I can stop the engine safely. That's pretty much all I need for this project. But what we've really got to appreciate is how beautifully simple these engines are. I love the fact that this piece at the top is the cooling mechanism, the brake mechanism, the start mechanism, and the spark generator. It's really nice. It deserves a clean up. I've given the engine a clean and a quick lick of paint, and I'm hoping if I keep moving it like this, you won't be able to see just how bad that paint job is. With impeccable timing, a shipment has just arrived from my sponsor, PCBWay. As you probably know, PCBWay offer a range of services such as PCB manufacture and assembly, but also 3D printing and engineering services like CNC and sheet metal work. I've never had some sheet metal work done before, so this is going to be a voyage of discovery. Have I got my CAD drawings right? Did I take the measurements right? Let's find out. Yoink! So in here we should have some brackets, which means I can get on and assemble the deck mount system, and most importantly a part that I can't get on without, which is this piece in here, which I'm excited to see, and that's the bit that joins the engine to the deck. Well, already they're looking pretty nice, these little folded brackets I had made up. Let's have a look in this one. Okay, this is the hanging brackets that are going to support the deck system off the side of the chassis. All in stainless steel, all laser cut by the looks of things, very nice. It's very well packaged. Well, it looks lovely. That's beautiful. CNC cut, folded stainless steel. Looks really nice. I just really hope I've got my measurements correct. If you remember, I had to measure these by hand because I couldn't find the specs on the engine. PCBWay have done a really lovely job of folding this. It looks identical to my CAD, which you'd expect, of course. If you have something like this to be made up, go and check out PCBWay's services. It's PCBWay.com. Like I said, they do PCB assembly, manufacture, CNC engineering, 3D printing, and sheet metal work. Go and check them out, PCBWay.com. Let's get this together. Now, do I want to ruin my weekend finding out if I've got this right? Those holes line up, so that's a good start. That's gone in. That's gone in. Yay! I got it right. I'm pleased about that. I realise that's probably really basic, but when you don't have a drawing of something and you have to measure it, it's always a little worrying that you've not got it quite right. Nice shiny stainless steel and a terrible paint job. Quick, let's hide it. Get it out of the way. I'm going to start assembling the rest of this frame, because if I can get this frame on and built up, I can drop this into the chassis, drop the engine on top. Not far off testing and cutting grass then. Most of the parts that form my side chassis here are again this extrusion, but these parts printed in Polymaker's polycarbonate. It's a lovely tough material, and that's the same for all my little dropping hinges and the actuator thing, and of course the little gears that, the tooth pulleys, which I'm still waiting for the belt for. Anyway, let's get this together. I have a little bearing recesses in the end of these polycarbonate pieces, and then there's a little adapter to take the square extrusion. This is why I'm using square axles, because I want to transfer torque. If I just move the front one back and forwards, this is going to do weird stuff. It's going to lift the front, and the back one could do whatever it likes. But by tying them together with the belt, the back one has to move at the same time in synchronization, and that should lift the whole deck up in one go. I've just reamed out the lifting arms so they'll take my nice M10 shoulder bolts here. You want a nice good snug fit. That's perfect. Now the distance from one side of the chassis to the other is 420 mil, at least on the CAD drawing it is, and that is 420 mil. Let's have a look at the back one. 420 mil. Boom! Get in! I love it when a plan comes together. I wonder if the chassis is actually 420 mil though, which it might not be. I'm going to measure it. Hang on. 420, maybe 0.5, so pretty good. Keyways in. There's one. There's two. And there's three. I'm happy with that. As per the original design, the original lawnmower, you have to take the chassis off and the plate before you can unbolt the motor, which is a pain. So, do I take that lovely folded stainless steel plate off and grind down that front fold so it's shorter, so I still have the strength but I can get a spanner under? Or do I just bolt the motor onto it and be done? The problem is it's going to be hard to adjust if I need to make any adjustments without having that. Conundrum. I finally made a decision and went ahead and bolted the engine down to the stainless steel mounting plate. So that now if I want to make any adjustments, I'll have to loosen the stainless steel plate from the decking to move the motor around. It all feels pretty solid though. I now have the timing belt, so I've been able to fit the front and back sections together. However, it turned out to be way too loose, so I've had a 3D printer shim that sits between the bearing holder and the aluminium extrusion. I can tighten this further using a stack of bearings on an M5 bolt screwed into an M5 nut within the extrusion. This tightens up the whole belt quite nicely. Well, with much huffing, puffing and a little bit of cussing, I managed to get the chassis over the engine. It was a little tricky getting this in, and I will say that this side is very tight. The air filter is actually touching the side there. I mean, it's not hard pressed up against it, but it is right on the edge. Let's see if this linear actuator and the lift mechanism works. That's heavy. Don't know which way around to go. Oh, okay. So that's one end stop. Oh, that's smooth. I think it's worked. That looks pretty good. Obviously working harder to bring it back up, but it is working. From this angle you can see that the left hand side is lower and I can lift it back into position. The cause of this problem seems to be the 20mm extruded axle going across the front, which is being allowed to twist across here. This twist is allowing the left hand side lift arms to drop out of position. There are a number of things I can do to limit the droop on this side of the machine. I could add a load spring which lifts this arm up, puts it under tension, or I could replace that front axle with a solid metal shaft that will stop it from torsioning, or I could replace the belt system with a single fixed linkage. However, none of this really matters at the moment. It just means my cut will be slightly skewed, and that doesn't really matter for a rough cutter. I'd rather just see if it works. I found this simple throttle mechanism that's made for lawnmowers that I'm going to use to replace the dead man handle on the lawnmower, which will operate both the electrical stop and the brake stop. I've added this brake cable adjuster to the end so that I can attach it to the existing brackets. I'm now going to use a special tool to put a double bend in this solid wire. First of all, I mark it up where I need the bend to start. This is the tool to do it with, but you're also got to make sure the orientation is correct because the cable won't twist within the sheathing. Here it is attached to the brake mechanism. Now I just have to tighten up the adjuster and we can try it out. For power on this machine, I'm going to use two of these Lifey P04 12.8 volt batteries. In series, that gives me a nominal 24 volts. These come with a BMS, a battery management system built in. So generally speaking, the BMS limits the battery to whatever its capacity is at 30 amp hours. So these apparently will do 40 amp hours each of discharge and 90 amp hours for 5 seconds. Now in theory, my motors could draw up to about 60 amps, between 50 and 60 if they're delivering 1000 watts. but it's very unlikely that I'm going to be driving this at full tilt all the time. If I'm using 1000 watts, then surely I would have stalled by that point. The good thing about these batteries is they're quite lightweight, and I found a great spot to fit them. This little piece down here, 3D printed, is the battery holder, and it will be mounted underneath this bracket, and of course the battery is a perfect fit, slides down into this slot here. I'm a little bit skeptical about these batteries and their data sheet. I've never heard of Mower before, but I did discharge one of them fully and recharge it, and it did take a full 29 amps of charge, so very close to its specified rating. So fingers crossed that the 40 amp BMS is true on their data sheet, because it actually says 30 on the back of the battery. I found this box, which is conveniently about the same width as the chassis. It's a simple electrical enclosure, so I can run a piece of rail on the bottom and attach relays and e-stop and Arduinos and whatever else I want to add. I'll drill some holes in the bottom and put some conduits in there so I can run my electrical system around the chassis. I'll also try and get the power amplifier for the motors in there, but I'm not sure it's going to fit. I might have to put that at the back of the machine. Here's the current layout of my electrical enclosure box. I've got an e-stop switch mounted on the top face here, and on the back side I've managed to fit that L-Faster motor controller. I'm just making up the power cables here, and I like to use this braided sleeving and heat shrink to tidy the cables up. The main function of this box is power distribution and an e-stop system, but I've left plenty of room for future development. We have our 40 amp circuit breaker, a relay for the e-stop system. This bus bar joins the two batteries together to give 24 volts. This is our solid state relay to switch the main power off, and our protection diode, and some terminal blocks for the rest of the power to the system. Before I power anything up, I'm going to ring through this circuit with my multimeter just to make sure I've got everything connected in the right position. And of course check for any short circuits. As an added precaution, I'll always power up equipment for the first time on a bench power supply that is current limited. This is much safer than plugging in batteries and finding out the hard way that you've got something wrong. There are 4 additional channels on the receiver and 4 buttons on the remote control that comes with this package, and they seem to control channels simply on and off, like these relays that I've got set up here. So I could use 2 of the channels with a changeover relay in order to control the direction of my linear actuator to raise and lower the deck. I'm going to use another spare channel with a normally open relay in series with my stop switch. This will give me the ability to remotely e-stop the vehicle. It also means the vehicle won't power up unless the remote control is switched on. I've done a bit of work on the chassis electrics. I've added a loom to both sides for the left and right hand motor that runs down the chassis. And of course I've added battery cables to my batteries. I still have to finish off the wiring for my linear actuator because I'm waiting on the radio controlled relays for that. I've added the engine stop loom here, which runs through this piece of silicon high temperature sleeving. That's because it runs past the exhaust pipe, and it runs in parallel with the existing stop mechanisms. I've also added these 3D printed battery clamps to stop the battery from coming out. I'm now going to install my electrical enclosure onto the chassis onto these 4 anti-vibration feet. I am slightly concerned that there will be quite a bit of vibration from the engine, so I have tried to use nylocks and anti-vibration washers wherever possible. So I assume that's powered up, we should hear it. Yep. No. Is it because my remote control was not switched on? Yes, there we go. Now it's powered up because the remote's on. Let's see if she works. Are they going forwards? They're not going forwards. Well, they're going forwards on that side, and this side they're going backwards. Have I got my left and right mixed up? What I didn't notice on the motor controller, there's a positive and negative for each motor output, but they'd switched the left-hand side positive and negative. I wired it positive to positive, negative to negative, but I need to switch them to reverse the left-hand side, and that should sort it out. Yes, forwards on this side, left. Yes, this side's going backwards, right, yes, backwards, yes, bingo. All I've got to do now is figure out how I'm going to get this off the table. because that's heavy.
This blade was looking pretty blunt, so I've just given it a sharpen up with a flapper disc. As soon as I've remembered how to reinstall it, we'll take it for a spin. No pun intended. I was going to ask my subscribers to name this new machine, but I'm fairly sure my English viewers would have come up with the name Mulchy McMulchface. If you don't know what I'm talking about, look up Boaty McBoatface. So I present to you Mulchy.
Well, it seems to be turning pretty well. It is a little front heavy, so the back end wants to spin out before the front. So that's the brake off. Let's try. All right, well, that's pretty good. Fired up first time, and the brake and shut off worked okay. Some grass over there. Oh, I was going to say, look at it go, and then it didn't. I got Mulchy running again. Let's see how far we get this time. Come on, Mulchy. Plenty of power. Yes, Mulchy. Give us a wiggle of them eyes. I'm well pleased with Mulchy's performance. It's a working machine. I might have to take it in and check everything's tight now it's been running for a bit, but it feels pretty good and it's cutting grass well. The whole deck needs to come up a bit. It's way too low. Let's take a look in the workshop to see if there's any damage done. I'm pretty keen to test Mulchy on the terrain that we saw at the start of this video, which is that embankment, which is quite steep. But before I did that, I wanted to do a few tweaks and upgrades. I also found out that the reason I was getting the droop on one side was that I'd fitted the brackets on this side in the wrong place. They were actually 10mm lower, so the whole thing was squiff. I was amazed it worked at all. Anyway, I've corrected that, and I've also lifted the deck by another 10mm, so that's going to give me more ground clearance. I've got a green LED for the main power and a red LED for the e-stop system. I've now got a stainless steel exhaust that comes out the side here and is routed across the engine. So that hopefully will keep that horrible exhaust fumes away from all the delicate 3D prints. I've also now got the up and down lift mechanism working on the remote. I'm sure this gradient doesn't look very steep on camera, but I can assure you it is, and it's pretty rough terrain. I've left the cutting height as high as I can. Wow, it's sliding down the hill, like traversing. Come on, Mulchy, get that weed. This is pretty challenging as terrain goes. So remember me saying that make sure you use anti-vibration washers. Well, there's a prime example. I'm missing a screw from there and I'm missing a bolt out of there because that's way too low. It may well be that I end up having to Loctite a lot of these if they keep vibrating out even with the washers on.
The lawnmower manufacturer says the maximum working gradient is 20 degrees, however the engine manufacturer says 15. This gradient is between 20 and 25, so I am over the limit.
I tell you now, this is a lot less back-braking than strimming all of this. I will have to come over it with a strimmer as well, just to tidy up the edges, but one thing you need to be really careful of is that your glasses don't fall off and the mower doesn't mow over them. And the other thing is to make sure they're not the really expensive ones that are prescription. Oh, that's not good. That'll be my nice sharp blade now blunt.
I've been hinting that there's more to mulchy than just mulching, and if I add this ball hitch to the back here, you can now see why I've left the back end so flat. Now I can hitch up a garden trailer. This one's probably a little bit large, but it's the only one I've got. Something tells me this is going to be a lot of fun and very useful. And technically speaking, is this not now a ride-on mower? It's really manoeuvrable and I can turn it on the spot. It's much happier running on the grass rather than the loose gravel because it gets a lot more traction.
I can no longer lift Mulchy McMulchface on my own, so I've had to set him up under my chain hoist on this temporary table. He's a bit of a lump, but that's good because you need a bit of weight to get grip. Mowing the lawn outside, I used Mulchy for about 1 hour or just under, and it used 1 tank of petrol, and I was surprised to see how little of the batteries it used. It only used about between 1/4 and 1/5 of the capacity, so that means I should get at least 3 to 4 tanks of petrol on each charge of the batteries. That's really good. One slightly worrying thing is I've noticed that the tyres are wearing quite badly already. Now I did drive them for a very short period of time on some concrete, but it was literally only about 6 or 7 turns and then came off. Now I don't know whether it was just that small period of time on the concrete or whether they're just a really soft compound, but I do feel like these are going to be changed regularly if I do drive it on a hard surface. There are of course modifications I'd love to do to Mulchy. I'd love to upgrade the electronics to include an Arduino, and I'd probably go with something with Wi-Fi so that I could connect it to my internet. If I added some lights and an internet-based camera, maybe I could use them for my nighttime security patrol. I like the idea of adding features. One feature that might be fun to add would be a strimmer arm that comes down, and then once you've done your mowing you could go around the edges and strim. What about a shovel attachment that comes down in the front like a proper skid steer? Might be quite useful. I can imagine if it snowed it would make a great snow clearing device, although we don't really get much snow here. One thing I must add is a tilt sensor to switch Mulchy off if it was to roll over or go above a certain angle. I did find a really nice electromechanical solution that I added into my e-stop circuit. The problem was that any vibration on the sensor would also trigger the tilt, so if Mulchy was bumping on the ground it thought it was tilting and would switch off the e-stop. So maybe I'll do that in the Arduino with an accelerometer or an inclinometer. I can't tell you how much more fun it is driving this round the garden with a remote compared to pushing a lawnmower. I bet my neighbours are going to want to use it. So let me know if you've got any ideas for upgrades that you could think to add to Mulchy, and of course don't forget to leave the comments below and like, share, subscribe, you know, the usual thing, and share to your friends because that helps the channel grow. Until next time, bye!